Hey pre-algebra, we're working in chapter 2 still, but right now we're going to move on to section 2.6, graphing in 4 quadrants. We only have one vocabulary word today, and that word is quadrants. The x and y axes separate the coordinate plane into 4 regions called quadrants. And look at this image here of the x and y axes, and we see that indeed we've got these 4 parts here. So this is actually called quadrant 1, and we use Roman numerals oftentimes to represent it. This is quadrant 2, quadrant 3, and quadrant 4. So here are the 4 quadrants, and each quadrant has its own characteristic. Like in the first quadrant, you notice both x and y values here are positive. So points that are in this quadrant, all the x and y values will be positive. What about over here? If you have points in this quadrant, these points will all have negative x values but positive y values. In the third quadrant, the x and y values are both negative. And in the fourth quadrant, all points that are found here, the x values are positive, but the y values are negative. Here in this example, we're going to look at ordered pairs and their names. So let's look at part A, or point A, that is. If we look at point A, we see we first name a point by how far out on the x-axis it is. It's out to -5, and it goes up to what it looks like to me +5. And so my ordered pair for this point is -5, 5. For B, on the x-axis we go out to -3, but we don't go up or down. We stay on the x-axis, so that means there's a change of 0. We're at 0 on the y-axis. In C, we go out to -1, it looks like, and then we go down to -5. So this point is -1, -5. In D, we go out to +2, up to 2. So D is 2, 2. Finally, with E, we go out to +4, but down to, now that's just terrible. I'm going to go with, because we can do it like that, to about 1.5. So that is +4 and -1.5. Hopefully when you guys are doing this in your examples, you'll see that there's a beautiful chart and a beautiful graph, but sometimes you can have values that are between numbers. I think I intended that to be on -2. However, when you don't know where it lands, sometimes you're going to have to estimate like we did here. In this next example, we're going to graph points and name the quadrant. So in part A, we're going to graph the point -3. So we come all the way out here to -3, +2. Then we're going to go up to +2, and our point is here. And this quadrant is quadrant 2. B, we have a -4, -4, -1. So we'll go back out to -4, and which is out here, and then we'll go up or down to -1. And so that brings us here. And that point is in quadrant 3. Next, we've got this guy that is on the axis, because on the y-axis, so we are at 0 and we go up to +5. So our point lands here, but this is a really good question. What quadrant is it in? It happens to be on the y-axis, so that was kind of a trick question. It's on the y-axis. And obviously it's between quadrant 1 and quadrant 2. Let's do D. D is -4, 0, so we go back here to -4, but we're right on the x-axis. So this one doesn't fall in either quadrant, though it is between quadrants 2 and quadrant 3. It is on the x-axis. And finally E, we see that E is placed +3, -4, 1, 2, 3, 4. That brings us down here, and that looks like 2 dots. Let's just make a bigger dot. Okay, so we see that 3, -4, or E, point E, is actually located in the fourth quadrant. And I can do it. There it is. So here we're going to actually graph a rule. So if the difference between two numbers is 5 and the smaller number is x and the larger number is y, let's make a function table for x and y, and then we're going to graph the ordered pairs. So I like to write the rule down. So what I realized the rule is y minus x is equal to 5, and then we're going to make a table. Let's let this be our x term and this one be our y term, and we're going to just choose some values for x, and then we'll plot them and see what we get. So I've chosen the following values for x, and then we're going to just plug it into the equation and see what our corresponding y values are. For x equals -3, that will be y minus, let me write it here, y minus -3 is equal to 5. To solve that, we need to keep change. And then so we know that some number plus 3 is equal to 5, and I hope everybody knows that that's 2. So 2 minus a -3 is going to give me 5. Continuing on with this next one, we're going to have y minus a -2, and that's equal to 5. Keep change. We do that only when subtracting. We see that some number plus 2 is equal to 5, and at this point we know that the answer would be 3. And you can probably sense a pattern already. Y minus a -1 is equal to 5. Keep change gives me 4 here, because 4 plus that 1 gives me 5. And so I can fill in my chart with this information, and this is what I get. So now let's graph. So here's my feeble attempt at making an XY axis. I'm doing the best I can. And then we're just going to take our time and plot points, and I'll use a different color to do that. So this first point is -3, 2. So I'll go out to -3, go up to +2. I had to adjust my graph a little bit. There's -3, +2, -2, +3 would be right about here. -1, +4 just here. 0, 5 here, 1, +6 here, more like here, 2, +7 brings us to this place, and then 3, +8 is up here. And what we realize is that this is indeed a linear equation. If I were to plug in points between these numbers, all of this space between them would be filled up by points that lie on this line. Okay, we've reached the end of our video, and our assignment is as follows. Please work on as much as you can in class, and if you don't get finished, you can do some at home as well. That's not a problem. Have an excellent day.